Hello and welcome again to Flipped Harbor for Pre-Calculus. In this video we're going to be talking about evaluating functions. So here's our list of I can statements for this video. I can evaluate for a function written in function notation. Now we're going to have to talk about what function notation is. I can find the domain of a function, and I can evaluate a piecewise function. So let's take a look at our outline. We're going to talk about function notation, that f of x stuff. We're going to talk about how do we evaluate for a function when we're given a number to plug in and when we're given a variable to plug in. We're also going to talk about how to find the domain of a function, and we're going to end by looking at what a piecewise function is and how to use it. So let's start out by talking about what function notation is. I like to say it's kind of a great way for bookkeeping. It's a way of writing functions that tells you what number or variable was plugged in to the expression. So when I say f of x equals x squared plus 3x minus 1, we use function notation because whatever I put in that set of parentheses tells me what number is getting plugged in to the rest of the function. So like I said, it's a great way for bookkeeping. What number did I plug in to get 5? Oh yeah, it looks like I plugged in 1 to get 5. Now if you plug in 1 into this, you don't really get 5. But let's take a look at what happens when you do plug in a number. So we're going to figure out what f of 4 is for this function, and we're also going to take a look, what if we plug in a little tiny expression, m plus 1. So we've got a variable, we've got a little bit of math going on, we're going to plug all that in to our function. We're going to see how to deal with that. So let's start with the f of 4. So whatever number, or anything for that fact, whatever gets plugged into those parentheses, that gets plugged in for x everywhere. Now, I really strongly suggest that you put whatever you're plugging in into parentheses. So you see, I've replaced the x not just with 4, but I've actually put it in parentheses also. That's usually not a big deal when we're plugging in a nice easy number like 4, but if we're plugging in a negative, it's a really great idea to do that. Or when we're plugging in variables, again, it's a great idea to put those parentheses in there just to make sure that we follow our order of operations, just to make sure that we're doing our algebra correctly. So let's go ahead and simplify this. When you square 4, you get 16. When you go 3 times 4, you get 12. So I've got f of 4 equals 16 plus 12 minus 1. Well, what the heck is that? It's 27. So f of 4 equals 27. So again, you can see this great bookkeeping that I'm talking about. I can see what number I plugged in. I plugged in 4. What number did I get out? I got out 27. So again, function notation is great for bookkeeping, keeping it straight. What did I plug in to get this number? Now let's move on and take a look at what happens when I plug in something a little more complicated, something like m plus 1. Now, whatever goes in those parentheses replaces x. And again, you can see that I use the parentheses. Really great idea. Always put it in parentheses and then simplify. Those parentheses are going to stop you from making really silly algebra mistakes later. So where I had x by that square, I now have m plus 1. It's in parentheses. The whole thing, m plus 1, is getting squared. Not just the m, not just the 1. The whole thing. That's why those parentheses are important. Next to the 3, in parentheses, I've got m plus 1. That whole thing, m plus 1, replace that x. I put it in parentheses again to drive home the idea that that 3 is not just multiplying the m, it's not just multiplying the 1, it's got to be distributed in. So let's do some simplifying. When I square m plus 1, I get m squared plus 2m plus 1. If you're not sure how I got that, make sure you ask. But really what I did is I foiled it. But you know, I've been doing this for so long, I know the patterns. I can do it pretty quickly. Distribute your 3. 3 times the quantity m plus 1 is 3m plus 3. And then I've got that minus 1 hanging out there at the end. So my next step would be combining like terms. I don't have anything like the m squared, so that's alone. I've got 2 m terms. I've got the 2m and I've got the 3m. And I've got plus 1, plus 3, minus 1. So my end result, whole new function, but now in terms of m instead of in terms of x. F of m plus 1, that's how that's read, f of m plus 1 is equal to m squared plus 5m plus 3. All right, let's talk about the domain of the function. The domain is the set of numbers that is going into the function. That is, it's typically our x values. It's the letter that's inside the parentheses in function notation, so it doesn't have to be an x. We could have f of v, we could have f of r, just kind of depends on what we want that variable to be for. And many times when we want to talk about the domain is just all real numbers. We can plug in anything we want. We can plug in positive numbers, we can plug in negative numbers, we can plug in 0, we can plug in big numbers, we can plug in little numbers. So quite often it's all real numbers. And I actually like to start out with, okay, let's assume that they're all real numbers, and then whittle it down from there. So sometimes functions are limited. So here we have a couple functions. We have a square root function, f of x equals x plus the square root of x plus 3. We have a rational function, f of x equals 6 over x plus 3 plus 2 over x minus 4. Now these functions carry some limitations to what numbers we can plug in. So what I like to do is think about, okay, well, let's start out with all real numbers, and then talk about what we can't use, what x cannot equal, or what x is limited to. So let's take a look at that square root function first. Whatever is inside the square root has to be greater than or equal to 0. Now if I solve that little inequality, I get x has to be greater than or equal to negative 3. So that is my domain. I started out with the idea that my domain is all real numbers, and I've whittled it down so that x has to be greater than or equal to negative 3. So I've got it in my set builder notation. Hopefully you watched the video on set builder. And again, this implies that x is part of the real number system, but then I've limited it some, and that limiting rule is in my set builder notation. Looking at the rational functions, what my limitation is the bottom of a fraction can never ever equal 0. So for the first fraction, x can't equal negative 3, because that would give me 0 on the bottom of that fraction. For my second fraction, x cannot equal 4, because that would give me 0 on the bottom of the fraction. So for this one, I know that I can have all real numbers, but x cannot equal 3 and x cannot equal 4. So I'll write it in set builder notation, the set of all x such that x does not equal negative 3 or 4. And I can just use a comma there for my or I could write out the word or. I've got a little bit of extra stuff that I didn't include before. This is just, if you want to, you can just kind of put a reminder that x is an element of the real numbers. Excuse me. Now let's talk about piecewise functions. Piecewise functions look really kind of scary the first time you see them because there's so much information coming at us. But really what we need to realize is that I only need to use one part of this piece at any time. I never use all three of them. I only use one piece. Well, which piece do I use? Well, it depends on what x value I'm using. So this function, f of x, is equal to x plus 4 if x is less than negative 2. So if my number is negative 3, negative 4, negative 5 billion, I just use the top part of that function. F of x equals x squared if negative 2 is less than x is less than or equal to 3. So I'm only going to use that middle chunk of this function right in the middle of my domain from negative 2 to 3. F of x equals 2x plus 9 if x is greater than 3. So I'm going to use that piece only when x is a number bigger than 3, maybe pi or 4 or 22 or 5 bazillion. Then I would only use the bottom part of this piecewise function. Now the important thing is just pay attention to which rule I use based on what I'm plugging in. So we're going to go ahead, use this piecewise function and figure out what f of 0 is and what f of 4 is. Now this is only two numbers. We're at most going to use two different rules here. To find out what f of 0 is, well, 0 is between -2 and 3, so I'm going to use that middle rule. So f of 0 is equal to 0 squared. I plug 0 into that middle piece of this piecewise function. 0 squared is 0. Since f of 4, I'm plugging in a number bigger than 3, I've got to use the bottom piece of this piecewise function. So I'm plugging 4 into 2x plus 9, so 2 times 4 is going to give me 8, plus 9 is 17. So the only thing you need to remember with piecewise functions, just use one piece at a time, look at what your x value is, where does it fit in? Maybe it fits in the first piece, maybe it fits in the second piece. Maybe there's 22 different pieces. It doesn't matter. I only have to use one of them at a time. Alright, so that's it for this video. Hope you got it down. I'll see you in class and I'll see you online.